Welcome back, fellows. In this episode, we are going to simulate a mixer and a splitter processes in Aspen Plus. So, this will help you understand how material streams combine and split in industrial processes. So, in this video, you learn how to connect a material balance. You learn how to connect a material streams, set a stream conditions, how to run a successfully simulation, and how to understand mass balance in Aspen Plus. So let's give it a start. Okay, so I've already opened my Aspen Plus as you can see it here. So let's start to specify our component. So my first component will be water. So I'll specify the water. After that, ethanol will be my second company. So after that, I have to specify the unit that I want to work with. So I want to work in metrics. So after that, I have to specify the method to be used in this simulation. Water is a solvent. Ethanol is a solvent, but ethanol is a hydrocarbon. So to simulate this kind of liquid where one is non-polar, one is polar. The best method to use is the NRTL, or you can use the UNIQUAC, which is also good for simulation liquids in Aspen Plus. But for this video, I want to use the NRTL method, which is I think the most common method that uh, is good to use in simulation liquid. So let's search for NRTL method here. So let's go up NRTL. Okay, here it is. Okay, so after that, I have to click the next for you to calculate the stoichiometric coefficient over there. After that, I have to proceed till everything is successful. So it's will running the initial step processes. So it will take a bit of time, but it will definitely complete so that we can proceed to building our simulation. So for this video, we will just use a two block, one a mixer, two a splitter, where the mixer which carries only mixing processes where we have a two-stream ethanol getting into the mixer, mixing with water, and we'll have a one stream connecting the mixer to the splitter. So from the splitter, we will have a two splitter because it's a splitter, so it's going to split the the product into two, the upstream and the downstream. So I'm just waiting in the two. I think it's finished. So okay, everything is finished here. So let me go to the simulation board. So here is our simulation. So now we are coming to build our simulation here. So we start to select our our mixer first, and then F splitter, or you can use any splitter that you want. So from here, I'll have to connect it. So from here, I have to connect our two streams, our two blocks, B to B1. Then I have to specify our first free stream. Okay. So now we have this block. So I have to specify the bottom product stream. So I'll just write the upstream, press enter, and the bottom stream, or maybe stream B. Okay. Okay, so I'll specify my downstream. Good. Okay. So from here, I have to specify the operating conditions. So I'll click the. So as you can see here, we have two entry stream, which is the water and ethanol mixing together here, connecting the mixing to the splitter. Then we have our top product stream, our down product stream. So I have to specify the operating conditions for the first one, which is the water. So for the water, let me say specify the temperature to be maybe 25 degrees C, and our pressure will be 1 atm. Then okay, from there then I'll specify the flow rate. So I'll say 50. We have 50 kilomole per hour. Okay. After that, then I have to specify the component. So because we are dealing with water, so we say 100% water and 0% ethanol. Yeah, I hope you are getting me. We are specifying 100% water, which is one, and 0% water, and 0% ethanol rather. So after that, then I'll just click the next to go to our next stream. Our next stream is the ethanol. So it's at 40 degrees C and 1 atm. After that, the component, okay, the flow rate, I think, let me give it 20 kilomole per hour. Then for here, 0% water, 100% ethanol. After that, then I have to click the next. So from here, we have to specify how how the block, how the product we split, whether it is a 50-50 or so let me say maybe 50. So here, what I'm doing here is simple. I'm telling the splitter how it's going to split the incoming, how it's going to split the because we have only two product stream, the top one, the down one. So I'm specifying here how it's going to distribute the splitting. So it will split the top and bottom 50-50. So this is what I'm doing here. So after that, I think everything is complete. So I'll just click. So all required input is complete. So I'll just click OK. Then simulate. So now it's been simulated. It's been giving us our simulation. So we just have to wait. So I think now it's done. Okay, it's done with some a bit of some warning, but I think it's normal. It depends on the type of the splitter that we use, but I think it has given us a resource. So let's check our resource. So we have seen our first resource. You can see the stream class. You can see the temperature, how the temperature changes. You can see the pressure is constant and the temperature too is constant. And because we specify 25, which is converted into Kelvin, we have molar fractions, we have a mass fraction, molar liquid fraction, mass solar liquid fraction, molar enthalpy, in, in calorie per mole, we have our molar densities and the rest. So these are the stream results. We can also check the mainstream. We can see 50-50, 1, 2, which is normal. You can see the 50% upstream, 50% downstream, which means you have 50% water upstream, 50% ethanol upstream, 50% water downstream, 50% ethanol downstream. So it's good. So this is how you do a simple mixing and splitting processes in Aspen Plus. So so, so if I learn Aspen Plus for the first time or preparing for a chemical engineering simulation, this series will help you guide you step by step. So in the next episode, we will simulate a distillation column in Aspen Plus, which is one of the most important processes in chemical engineering. So I will leave you here and see you in the next video. Bye.